Good morning, grade 10. Hope you are all doing fine. This is Miss Pamela Teeny giving the physics course. Today we are going to continue with chapter 19, section 2, electric force. So if you can all please open your books on page 685 so you can follow up with me. Electric force and gravitational force. It's interesting to compare Coulomb's law for electric force and Newton's law for the force of gravity. As you will see in this section, these two laws have a lot of similarities. So recall that Coulomb's law describes the electric force, which we already studied in the first part of this section. The electric force is equal to K times Q1 times Q2 over R squared, where F is the electric force measured in newtons, Q1 and Q2 are charges measured in coulombs, R is the distance between the charges measured in meters, and K is Coulomb's constant, which is equal to 8.987 times 10 to the power 9. However, Newton's law describes the gravitational force, which is F equals G times m1 times m2 over r squared. F is the gravitational force measured in newtons, m1 and m2 are the masses measured in kilograms, r is the distance measured in meters, and G is the gravitational constant equal to 6.67408 times 10 to the power minus 11. So you can see the similarities between the two laws, where G and K are the constants. They are multiplied by two physical quantities. In the law of electric force, the quantities are Q1 and Q2. However, in the law of gravitational force, the quantities are M1 and M2, and they are divided by the distance squared, the distance between the two masses or the distance between the two charges. So if you compare the two equations, you can see the similarities because they are very obvious. And to be more precise, we can write them. The similarities between the two laws. 1. In both, the force is inversely proportional to the distance between the objects. So the electric force decreases if the distance between two charges increases, and the gravitational force also decreases if the distance between the two masses increases. 2. In both, the force is directly proportional to the magnitudes of a physical quantity. For electric force, the physical quantity is the charge, and for gravitational force, the physical quantity is the mass. So if the masses increase, the gravitational force increases as well. And if the charges increase, the electric force increases as well. However, there is a big difference between the two laws, which is the force of gravity is always attractive, whereas the electric force can be attractive or repulsive, as you can see in the figures in front of you. First, we have two masses. The gravitational force between them is always attractive. They always attract each other. As you can see, F1 is towards M2 and F2 is towards M1. So M1 is attracting M2 and M2 is attracting M1. However, in the figure, in the lower part of the figure, we have two charges. If they are different, they attract. And the charge 1 attracts charge 2 and charge 2 attracts charge 1. But if they are the same charges, both negative or both positive, they repel. So charge 1 repels charge 2 and charge 2 repels charge 1. Gravity dominates in astronomical systems. We are going to see why. Because the electric force can be attractive or repulsive, the total electric force between neutral objects such as the Earth and the Moon is essentially zero. So basically, the attractive and repulsive forces cancel one another. This is why the total electric force between neutral objects is zero. But this is not the case with gravity. Gravity is always attractive, as we already explained. This leads to gravity exerting a larger total force on larger astronomical bodies, because we indicated that when mass increases, the force of gravity increases as well. So the larger the astronomical bodies, the larger the gravitational force between them. So between the Earth and the Moon, there is a huge gravitational force, but there is zero electric force. Not because it doesn't exist, but because the attractive and repulsive electric forces cancel each other. This is why gravity dominates in astronomical systems. On the other hand, electric force dominates in atomic systems. So inside an atom, the electric force dominates, and we are going to see why. The electric force rules at the atomic level, where gravity plays essentially no role. To understand this more, we can compare the electric and gravitational forces between a proton and an electron in a hydrogen atom. So we are going to do an example and to calculate the electric force and the gravitational force between a proton and an electron in a hydrogen atom, and we are going to compare these forces, and we'll see which one dominates, which one is larger. Now look at the figure in front of you. You can see the electron and the proton in the hydrogen atom. In order to calculate the electric force between them and the gravitational force between them, we need to know the distance between them, we need to know their masses and their charges. We already know their masses and their charges, and I told you that you need to know these quantities by heart. So the mass of the electron is 9.11 times 10 to the power minus 31 kilograms. The mass of the proton is 1.673 times 10 to the power negative 27 kilograms. The charge of the electron is negative 1.6 times 10 to the power minus 19 coulombs, and the charge of a proton is positive 1.6 times 10 to the power minus 19 coulombs. The given is the distance between them, which is the radius of the hydrogen atom, equal to 5.29 times 10 to the power negative 11 meters. First, we calculate the gravitational force between them using the equation that I already stated in this section. Fg is equal to G times Me times Mp over R squared. Me is the mass of the electron and Mp is the mass of the proton, so they are M1 and M2. G is equal to 6.67 times 10 to the power minus 11 into 9.11 times 10 to the power minus 31, which is the mass of the electron, times 1.673 times 10 to the power minus 27 kilograms, which is the mass of the proton, divided by the distance between them squared, which is 5.29 times 10 to the power negative 11. The answer is 3.63 times 10 to the power negative 47 newtons. Second, we calculate the electric force between them, also using the equation that we already stated in this section. Electric force is equal to K, which is Coulomb's constant, times Q1, charge 1, times Q2, charge 2, the magnitudes of course, over the distance between the two charges squared. K is equal to 8.99 times 10 to the power 9 into the charge of the electron is 1.6 times 10 to the power minus 19, and it's negative. This is why we put the absolute value, because we only care about the magnitudes of the charges, times the charge of the proton, positive 1.6 times 10 to the power minus 19, over the distance between them squared, which is 5.29 times 10 to the power negative 11 meters, and the number is squared. The answer is 8.22 times 10 to the power negative 8 newtons. So we can already see the difference between the two forces. The gravitational force is very small relative to the electric force. In order to see this difference more clearly, we compare the two forces by dividing them together. Electric force divided by the gravitational force. So 8.22 times 10 to the power negative 8 newtons divided by 3.63 times 10 to the power negative 47 newtons. And the answer is a very huge number. So this enormous factor explains why the force of gravity is unimportant in atomic systems, because the electric force is much, much bigger. So the electric force dominates in atomic systems. Since we already stated that the gravitational force dominates in astronomical systems, we can talk about black holes, because black holes are a very important example for how gravity rules in astronomical systems. Gravity is behind the formation of black holes. What are black holes? They are objects whose gravity is so strong that not even light can escape from them. This is why they are called black holes. They are black because not even light can escape from them. This is how strong their gravitational force is. If a star or other object comes too close to a black hole, it will be pulled into it, as shown in the figure in front of you. So you can see the black hole pulling the star into it. This addition of matter makes the black hole's gravity even stronger. So the more objects the black hole pulls inside, the greater their gravitational force. So in astronomy, it is truly gravity that rules and not electric force. Now back to Newton's law of gravitational force, which we already stated in this section above. F is equal to G times m1 times m2 over r squared. This is the equation we use to calculate the gravitational force between two masses. We can rearrange this equation to know the unknown mass if we have an unknown mass and we know the gravitational force between it and another mass, and to know the distance between two masses if we know the gravitational force between them. So by rearrangement, the unknown mass is equal to F times r squared over G times the known mass. And to know the distance between the two masses, we use the equation that you can see in front of you. R is equal to radical G times m1 times m2 over F. Please, as a homework, solve the following problems. 1. Compare the electric force and the force of gravity between an electron and a proton that are 4.45 times 10 to the power negative 9 meters away from each other. Number 2. What is the unknown mass of ball 2 shown in the figure below if the gravitational force between the two balls is 17 newtons? Number 3. How far are the Sun and Earth from each other if the gravitational force between them is 3.67 times 10 to the power 22 newtons? Notes. To change from centimeter to meter, you divide by 100. To change from grams to kilograms, you divide by 1000. Do your research to know the masses of the Sun and Earth in order to solve number 3. Your homeworks must be submitted on Tuesday, April 7th. Thank you and good luck.